Hello, everyone. Let's get started again. Uh, in our last video, uh, we have done some exercises, some practice sessions in summation convention. Also, we try to familiarize with the concept of index notation. Uh, in this video, I'm going to discuss the uh, definition of dot product and cross product in terms of geometry, and also we will discuss some other properties of vectors. Okay. uh, so again, let me draw the vector. Let's consider a vector again. Okay, x1, x2, x3. Okay, right. So now let's say this is our x1, x2, and x3, right? Okay. Uh, Now let's take a vector from here. Yeah. So this is our vector. Again, this vector you can make as decomposition along uh, right. Okay. So along each coordinate axis, right? Okay. Yeah. Okay. Yeah. Then yeah. Okay. Yeah. Let's keep it here, right? Okay, this is, let me change it to hidden line. Okay, so this one also hidden line, and this also a hidden line. Okay, it is, I think, too much tilted. Let me keep it like this. Okay. Yeah, now it's fine now. Okay, yeah. Yeah, and now here, the component, let's say this is our vector V. So now the component along this way, right? So this is V1, sorry, V2. This is V1. Okay, so this is V3, right? So this is our V3. So now you studied three dimensions, 3D systems, right? When you studied, if you want to find the vector, the magnitude of the vector, this we represent as Vi. This equal, it's a Pythagoras, right? So you have to apply Pythagoras theorem for three dimension case. You will get V1 squared, V2 squared, V3 squared, right? Okay. So now if you write it in index notations, uh, you can write it this way, right? It means like you can write it as uh, it is kind of a dot product, right? You can write it this one like V vector dot with V vector, right? And you can write this way, right? Because you remember V1 vector dot V2, two vector dot product, V1, V2, V1. Okay, I will write it this way, right? Instead of V1, uh, vector U, vector V. So you will write it U1, V1, U2, V2, U3, V3, right? So now if I multiply the vector with the same vector, so both is V1, V1, V2, V2, V3, V3, you will end up with this one, right? V1 squared, V2 squared, V3 squared. Okay, so that means this is actually you can write it this one as in index notation. You can write it Vi dot product with Vi, right? Uh, yeah, in this case you can write it Vi, right? Okay. Now this is the uh, index notation of your uh, magnitude of the vector, right? Okay. Now, what I'm going to do, I'm going to use these definitions with to define the dot product, right? Okay. So let's take two vector one along this way, and vector two is this way, right? Okay. So let's say this is vector A. This one is vector A. So this is vector B. Okay. So now I'm going to take vector C this way, right? If you want to apply the vector addition rule, this will be like A vector minus B vector, right? So only thing you have to change the direction of this one, right? If it is follow this way, then this is the resultant, right? So if we change this vector into the another direction, it will become minus b plus a, that is actually a minus b, right? Okay. Uh, then I'll take one more thing. So let's take the angle between these two vectors is theta. Okay. So I'll erase these things now. Okay. And then yeah. So now for this triangle, if I apply the cosine rule, right? Cosine rule. Uh, if you apply the cosine rule, this magnitude, right? I will write like A, B, C, right? So if you apply the cosine rule, you will get BC squared equal AB squared plus AC squared minus 2AB AC and cos theta, right? Okay, this is the cosine rule, right? So now for this one, this is actually I will take as this one is my vector C, right? I will take this is vector C. Now BC is actually vector C squared. Okay. Plus AB is magnitude of vector A squared. AC is magnitude of vector B squared minus 2 A vector uh, B vector magnitude of B and cos theta, right? Okay, right. So now what I'm going to do, this C squared, right? So actually this one, right? So in from our previous definitions, V squared, you can write dot v, right? Okay. So now using this, right? So now I'm going to write, instead of c, I'm going to write c dot c, right? Okay. I'm going to use this one, right? Okay, I use this one, then I can write this way. So this one, a vector times a vector. This will be b vector times b vector minus 2. This I will keep it as it is, right? Okay. So now C vector, actually this one, right? A vector minus B vector, right? So therefore A vector minus B vector dot product with A vector minus B vector, right? Then this side, it will be same, right? The same thing will come here. So I'll copy this one, paste it here, right? Okay. Okay. Now this is like a dot product, right? So I can write it like this, right? Just eliminate this one. A vector dot A vector. This is like eliminating the brackets, right? Then minus A vector times B vector. Okay. Here, uh, this side, again, these two minus B dot A. This is scalar product. You can change this sign, right? You can switch it. Nothing will change, right? So that means A dot B. Okay. I will move it with this side. So now finally minus b into minus b, that will become plus b vector times b vector, right? This is a dot a, b dot b minus 2 magnitude of a, magnitude of b cos theta, right? Okay, so now this part, this one cancel out, right? So finally we'll end up with minus 2 a dot b equal minus 2, okay, cos theta. Now this minus 2 cancel out, right? So therefore a dot b, magnitude of a, magnitude of b, and cos theta, right? So this is something you studied, right? In your mathematics, right? This is the proof for that definition, right? So this is the geometric representation of dot product. Okay, so that means a dot b, magnitude of a, magnitude of b, the angle between those two vector, right? So this is actually the cosine rule, right? That's what you must know, right? It's nothing. It's not a definition, but in the cross product, right? I will write it that one also. This is for the dot product, right? Okay. But the cross product one, it's a definition. There is no way to prove this one, right? Cross product. So that means vector A cross vector B. There's a equation you studied, right? A, B, and sine theta. Then also you will get one normal vector, right? Okay, E, N. Okay, so this is definition. There is no way to prove this one, right? This is by definition. They define this way, right? Okay, right. So again, you must remember this one also, right? These two. Okay. Now, what else? Okay, I explain you the dot product and this one. Okay. Next, yeah. Okay, next let's understand the geometric representation of these two, right? Okay, let me move to the next one. Okay, here let's take the dot product, right? What is actual the physical meaning of dot product? Okay, let's consider. I will take one scenario. Let's take one box is here, right? Uh, I apply the force this way. Then with respect to this horizontal plane, uh, let me extend this line. Okay, so let me make it, this is hidden line. Yeah. So now this is force, right? This force is a vector. Okay. Now let's say this angle is theta. Okay. Now you move this box uh, along this floor, right? Okay. Now let's say this is O, this is X. So now if I want to take the force along this OX direction, okay. So what I have to do, I have to consider the force along this direction, right? So that means I have to decompose this force along this direction, right? Okay. Yeah. Now this force will be my magnitude of F into cos theta, right? Okay. Right. So this one, I will make this the name of this component projection of uh, F along this X direction, right? I will write it like this. Okay. So that means uh, projection of vector F along this X direction, actually this one, right? F cos theta. Okay. So now let's say this projection of F, it is one vector, right? No, because this is now the this one, right? What you call the value magnitude, right? So if along the x direction, let's say I have a unit vector along this x direction. Let's say that unit vector is E, okay, along this x direction, right? Now this unit vector and this F, I can write the dot product, right? So if I apply the dot product unit vector in this one, F dot E, right? So that means magnitude of F, magnitude of E, then angle between these two is a cos theta. But you know magnitude of E is 1, right? Because it is a unit vector I considered, right? So that means cos theta, right? So now you understand what is the physical meaning of the dot product. Actually, the dot product gives the projection of one vector along one direction. Let's take our previous case, right? So now vector B, now this is vector A. Okay, right? So now this is vector A, this is vector B. Actually, if I want to decompose this vector B along this vector A, okay, vector B, okay, vector B along this vector A, Sorry. Okay. I have to make this one, right? Okay. Now I want to calculate this value, right? How can I calculate this value? What I have to do, that means this is actually, if it is theta, now my value is b cos theta, right? This b cos theta, how can I calculate this one? Dot product of this b and unit vector along this a. That means dot product b dot with unit vector along a. But how can I calculate the unit vector? The vector I have to normalize, right? So that means divide by its magnitude. So this is actually this one, right? Because this is very important, especially when you calculate. We will study something called directional derivative later. In that case, directional derivative, we apply this one a lot. This is very, very important properties of this dot product vectors. Okay, right. Right. This is the dot product. Okay. Now let's understand the similar way the cross product, right? Uh, let's say the cross product definition. Let's understand the cross product definition. A cross B equal magnitude of A, magnitude of B, and sine theta. Then you have the normal vector, right? Okay. Now let's take the situation, right? Let's say A vector, B vector, and A vector. Okay, right. Now this is vector A, vector B. Right. So now consider A is there. A mean magnitude of A, vector A. So now consider this one, B sine theta. What is B sine theta now? B sine theta, actually this one, right? Okay. B sine theta, actually this vertical height, right? So let's say this is H, this is H, this is actually the H. Now, if I make this one, this parallelogram as a parallelogram completely, if I complete this parallelogram, okay, now you see B sine theta is a height, but this one is a base, right? What is actually, let's consider this is just the direction of that vector, right? So that means A cross B, it is coming out of this paper, right? This plan. So now, if I consider just the magnitude of this one, that means A cross B magnitude, vector A that is base, right? Multiply by, so I will put bracket, okay. Height is H, it's a height. Base into height is actually the area of this parallelogram, right? Area of parallelogram. Okay. I think parallel. Okay. I think my spellings are not correct. Parallelogram. Okay, check the spellings, right? Because this English is not my my mother tongue, right? Okay, right. Uh, okay, so this is the physical meaning of the cross product. Cross product actually it's giving yeah, it is giving the area of the parallelogram which forms uh, as a side of that particular two vectors, the two vectors which we considered. Okay, right. I think let me stop this point in this video at this point. Then we will discuss further in next points, right? Next videos. So again, if you have any questions, just let me know in the comment sections. Then I can improve my explanation. So if you need any further explanation, some points it's not clear. If I do any mistakes, typos or anything, just let me know in the comment section, right? Also, please share with others. Then definitely it will help to everybody.